Okay, I think that's everything. Let's just double check. Um, okay. Oh, shoot, I forgot to change that, but it's okay. Uh, right. So this is next day. I did a little bit of work, a small amount, but it was just some fixing. I'm gonna go over what it was. It's not huge. So this was the dungeon player. Uh, it's a lot smaller than it was before, and I was just doing a little bit of experimenting. But the idea is that, well, not a lot, but I've shifted things around because I figured. So the way inheritance works is that you can have code at higher levels in the inheritance, and then scripts that inherit from that, in this case, like persistent entity, and then above persistent entity, it's just entity, but scripts that inherit this get the features of what they're inheriting from, right? So, for example, in this give me, oh, oops, there we go. So in this, I was just working on this. Maybe this, I'll get to this in a second, but basically, this is just a rehash, effectively, what I went over yesterday. But if you go through persistence, so I went to extending persistent entity, I think I can just hold control. Yes, there we go. So this, if you see there's nothing in here, this is going to be when I build up the data structure where it's going to initialize the persistent entity every time that you start the game or load into an area that this persistent entity is supposed to be in, right? And that's going to be managed from a different class. Probably the game manager is what I'm thinking. Like when you, it's going to have like a method of knowing these particular persistent entities should be in this area, and so it will load them, and all of that persistent entity data is going to be updated here once you load into that area. Um, yeah, so we'll go back further into entity. This has a whole bunch of doodads. So there's some stats here, but these stats are really just they're there because everything is going to have it, right? So this is kind of this almost like runtime data. So the idea is that this runtime data is going to be informed. Lower level is not informed here, or it can be through the set stat, right? But for the most part, it's not informed here. It's informed at a lower level. It's a little bit different because so in Unity you would have like you could inherit set stats in right set stat in Unity, and you could have something like base and so on, right? That's a thing. But in this, I don't know. I have to look up if there's actually like a base call to be able to override this, then call its base function, and then just populate it through the base function, right? Because then I could set this up to return a bool of true or false if it did populate, and then I can go back to whatever is overriding and say, hey, yeah, this populated, so you don't need to continue with whatever other processes you're doing, which would be pretty nifty. That's something that I like about C Sharp that I have not seen be a thing yet in Godot. So, hello, and this is, I think I fixed the audio enough that it should be I should be coming through much clearer than I did yesterday. Okay. So yeah, basically what's going on here, this stuff was from yesterday. Nothing really changed there. I implemented these state machines. I think that was from yesterday also. Uh, and we got this to work. So yeah, part of the problem was that this is instantiate, not instance, and in Godot 3 it was instance. So in Godot 4 it is scene.instantiate. The problem with Godot is not even the language. I don't mind GD script. It's just stuff like this, right? There is nothing to tell you, yeah, instance is not a thing. In Unity, you'd at least get something like, okay, this is deprecated, right? It would probably still work, but the function itself would be deprecated. This, it doesn't. And if I type it out, instance, like that, it'll actually just read it as correct until I try to run the game, and then it'll just crash. Right? So, like now, if I go back, game runs fine. But, yeah, so well, let me show you the game itself. Uh, Hold on. I think I actually need to do something else with OBS. Give me 1 second. I need to switch it from being this. There we go. Okay. So the idea is that I can do this now because you probably couldn't see the game before. There we go. All right. Now keep in mind, this is working with the ability system that we made yesterday. And this is, I'm not sure if I came through yesterday clearly, but it's based, I can't remember his name now. I'll get it probably later on in the video, but, or stream rather. But the idea is, it was from another YouTube channel that I had seen it. So I just took it and said, hey, let's see if this works, because it's very similar to the system that I had made in Unity. So it's like, this is awesome. It's similar but not the same. The difference between the system that I had in Unity and this is something that I'm going to be exploring today, which is the difference between, where is it? It is dungeon movement. This is the ability. So this extends node. But in Unity, the equivalent of what I had done was something that extends resource. Right. And so today I kind of, maybe later today, I want to get towards exploring the resources part. So this is actually what's controlling or what's allowing the player to move. The interesting thing, and for any Unity developers that are interested in this, is how to use scriptable objects. Now, there's tons of ways to use scriptable objects in Unity. I'm not going to go into that entirely, but the philosophy is still the same. If you're dealing with data, you have two ways of handling it, right? One way is that you're using, well, it's actually one way. There's only one way to handle data in my view. I mean, maybe there is a second way, but I don't think it's stable. I've tried it. It's not stable. It's a lot of work to get it to do what it can do when you can just use a regular script to get the same job done with much less overhead and much less hassle. So the key to data is that data does not exist at runtime. The problem with this is that this exists at runtime. Well, sorry, let me put it a different way. It doesn't exist as it doesn't take memory in runtime. The data itself, it exists as data on the hard drive, but it's not something that is in RAM. Um, so the key here is a couple of things, and it's the main issue. Let's say I had parameters here, right? And let's say this was not node, this was resource. So we're going into a hypothetical. This was not a node, this was a resource. There's a difference between them. I'm about to go into it. So the a resource would essentially be data, right? It just exists. It can be read from. So there is no intention of writing to data. All right, you shouldn't even be writing to data. If you're using scriptable objects, you don't write to the scriptable objects. And there's a reason for that. You can if you choose to, but it gets very dangerous to do that because as you switch between scenes, the references might not be the same, and now you're referring to data that, or you're getting values from data that's like ghost data because the reference is a ghost. It doesn't actually exist. So you're getting two pieces of data, and then the data itself is going to be still looking for like references if you've tied them together in that way. Um, so there's just a lot of complications that can arise from writing to data versus writing to script in memory. Um, it's annoying, and it's just something that you don't deal with if you avoid it, like what I'm doing here, which is the way that this should be done. There are no properties on this one, but you can put properties into, again, let's say that this was a resource. You can put properties here. The idea, though, is that if you put properties here, you're only using those properties to read from it. And when you read from it, you're taking those properties and then you're putting them into memory. And when you take those properties and put them into memory, what you're changing, if you change those properties, is not the properties on the data, but the properties in memory. And that's how that works. And you can have a separate save load system, which is what I'm also going to be working on today, to deal with memory itself, like just how things should be loaded and how things should be saved. Uh, for the most part, though, this is another way of handling data or allowing data to help you with your game, which is to simply just make a reference to data and then say, hey, I want you to run execute. This doesn't store anything, right? All it's doing is communicating back to the script and saying, this is, if you execute this process with the information given, you're going to get back this result. And it basically is going to execute this. Now, the benefit of having this in as data, which is what I'm going to try to experiment with today. I want to see. So in the original guide, there's probably a good reason for it. But I can't find that reason here. He used node. I want to see if I can use resource and do this. Because this comes with the added problem. In my view, it's a problem, but I mean, it is what it is, which is you have to instance it, which means you're adding it to memory. So part of me is saying, why am I adding this to memory? I can just load it. But I left this here because I like just having null checks. Uh, and then instantiate. We do an instantiate call on it. But we don't do an instantiate call. Rather, instead, what we do is we store its properties, right, as a shallow clone of the data. It's usually we do this in an initialized process, right? So what we would actually do is we would have like a var data or something. Var, I guess, movement, right, is what we would store. And we would simply just have that reference to that piece of data. And when we called it, I see this is the problem, right? I don't know if that would work proper. I have to really, maybe not today, I'm going to work on that. Tomorrow, I need to do some more research on it. But the idea is this has to instantiate, and I kind of don't want to have to do that. If I have to, then I have to, but I don't want to have to. I would rather just change the references as needed, which would make it much more like scriptable objects rather than instantiating. Because if, let's say I have like 100 enemies on scene and they all have these different things, I don't want to be instantiating a ton of these different things. It's already enough that I am going into um, data and getting these references, right, on load. Instantiating on top of that is something that, I mean, it only happens on initialization, but it's still a thing that if I can avoid it, why not? Um, so let's look at the tasks for a second. So I've updated this a little bit. I feel like as if I've gotten the primitive art for the tiles in. I don't really care to add more yet. The art for the character is fine. Um, the ability system, I mean, that's pretty much working. We just have to make the attacks. And the entity script, I think, is done. I don't think I'm going to be making any more changes to that for now. Um, the thing that I want to handle today is this. 2D. There we go. I want to do a couple of things. So I want to finish up the movement script a little bit. So probably going to be making another. I'm debating if it's going to be an ability, right? But it's probably going to be an ability, and it's going to be something like this. So I want a character to go like this to this, and basically just face the other direction. Um, that's the idea. So by default, positive means that the character is facing right. So we have that bool that you saw me adding earlier. Uh, the sprite faces right. So this is something that's going to check to see if the default position of the sprite is on the right. So whenever we make a scene with a character or whatever, if the sprite that we're using is facing right by default, then we check that off. That's going to be used to check to see if negative value on X scale is going to make us face left or not. Um, so let's go back to the task again. So basically, the setup, the play data. So this is the actually this is going to be part of this. So let's put this here also. Right? So we have to set up the play data, save load system, and then implementing the uh, persistent characters and instance character structure. So persistent characters are characters like, for example, we can have a player be a persistent character, right? And I'm debating whether or not the player should be an instance character or a persistent character. So in this game, the idea is going to be that you have characters that are other NPCs that are have persistent data, right? There's time in the game. There's persistent data that goes along with that. So the idea is that we also have other things that are not persistent. Um, and so uh, in the scene, so like regular enemies, like the slime that you bump into is not going to be persistent. That's something that is just pops up. So the structure for how to get that creature's data is different than the structure than how to get a persistent creature's data. The persistent creature is going to be have their data stored in the whatever the game data structure is that we come up with. Um, and then when the scene loads that persistent character is in, that character will then uh, be initialized effectively in that scene. Right? Their data is going to be loaded from the game's data. So this is going to require a couple of things. First, it's going to require a manager class. I'm debating maybe I should call it persistent character manager. And then the next thing it's going to require is the character. Yep, sorry. The next thing it's going to require is the character data itself. And the last thing that it's going to require is the dictionary that contains the character data. So the debate for me is, should the character data be something that is a separate class of, or should the play data, is what I'm going to call it, be a separate class of the and I think it should, right? So the idea is we're going to have a dictionary in the manager, and the dictionary is going to have a key, and that key is going to be some ID that's unique to the character is what I'm thinking. Now, it could, in Unity, we would have something called a GUID, right? And we could just generate a GUID, and that would be it. That would be a very unique key. It's like a 1 in a billion chance that it's replicated by anything, or rather, it already existed. Um, I don't know what they use in this, uh, in this, uh, in Godot, what's the equivalent of it, but I'm pretty sure they have something. Um, and then essentially the next step is going to be to have that class, that character data class. It's going to store all of the values. So the health value, max health, stats, everything is going to be stored in there. When the scene loads, now this is how I would normally do it in Unity. I would have a interface on the character, and in that interface, it would have a pre-built things that should happen once the character is ready goes off. One of those things is it would send an event out to the managers, to the manager class, to get this entity's um, information from the manager class. Hey, I need to be initialized effectively, is what I was going to say. And then the manager class should then say, okay, I got you, and returns back that entity's information. Now, there's a couple of problems for me here. Well, first, let's start with the good news. There's good news and bad news. The good news for me is it's very easy to do that in Godot, where I can send the information and uh, connect with the thing that wants the information, right? I can just call, let's say, character data, get the character data for that particular entity in the dictionary, and then just pass in like after I send the signal on ready, I can send that signal with the script itself, in other words, self, and send that forward. Then it's supposed to communicate back through that. And that's fairly easy. It's going to be a variable, and it's like whatever that variable is, dot initialize character data, right? Whatever the character data it's found. The problem is the character data itself. And so, I think what's the issue is that my brain is trying to find a modular way of handling it between the player and the rest of the persistent cast, and there isn't one, right? It's going to be that the player um is always going to be in the scene, so the player just has to be handled a little bit differently, or is almost always in the scene. So effectively, the manager, right? The manager or the character data needs to have a track of what scenes the character is in. But if the character happens to be the player, then it's always in the scene, and it always gets pings out to the player, or rather, it always pings out to the player that, hey, this is your information. But how do I let the player know this? That, you are the player. Here you go. So the manager doesn't know who the player is, right? It just has the character data itself. So it has the origin of the signal is where the issue is for me. Um, it usually is better, at least with actions. Unity events are a little bit different, but with actions, it's usually better to have the manager class be the thing that subscribes to an event, right? It's usually better that way because when you have one thing that's just subscribed to an event from multiple things, then it's not really that big of a deal. It's the other way around. It creates a lot of memory drain. So I think let's give it a shot. Let's try it out. Let's see what's going to happen. So today we're going to be making the manager class for the character data, and the manager class is going to be responsible for um sending out the data, recognizing and sending out the data. We need to create a unique way for the player in the data structure. So probably like just simply a bool that does a quick check is player, or is player data, right? And so once we send the signal, we can send a signal and we can say, hey, I'm the player. But now we come back to the question. Well, no, 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 no. I think we've got it. I think we've got it because then otherwise the only thing. So there's a couple of things it cares about. The scene, the character data has to keep track of the scene that the player is in. Got it. Okay. Where the character is in. So let's create that script. So this is going to be a manager script. Create new script, and this is going to be character data. Should I put character? Persistent data manager? Yeah, that's better. That's much better. Create. Okay. And then we also are going to need a data class. So this is going to be create new script character data. Okay. And I've never used a dictionary in Godot. Extends node. That's fine. I think it should extend node. Um, yeah, this should extend node. I'm pretty sure. I don't want it to extend resource. Can it extend resource? It's a good question. That is an excellent question. I don't know. Should it extend resource? Let's go back to Godot real quick. There we go. Oh, should I try that or should I go with what I know already? That's the question. All right, let's give this a shot. I'm gonna try something, I guess, a little bit different, but we're gonna go to the hybrid plan here. It's gonna be a little bit different and a little bit of the same. All right. So let's see, game. Um, okay. So first we're going to grab this. This is something you guys are not seeing right now, but you'll see it in a second. Okay, so this is the character, the persistent data manager. So the very first thing that I want to get out of the way is the save load system, right? So we can get rid of this because this doesn't exist yet. This doesn't exist yet. This doesn't exist yet. This doesn't exist. There you go. So this is how I just put this in because this is my only experience with a dictionary. So I want to ensure that I have the information that I need. But this is not how we're going to do it. We're going to go with a little bit more of a verbose solution to our issue. So now the next thing is the data, character data, right? And I think we can just get rid of all of this. This thing is not node, right? This is just data. That's it. There's nothing else that's going to be in here. Okay, so we know that we're going to need a var name string equal to nothing. Var bool. Oh, whoops. Var is player. Bool. Bool's false. I don't know why this string is maybe. I guess that's it. That fine. I guess that's it. Okay. Let's rename this actually. Rename. There we go. In Unity, you can't actually even rename stuff like this. That's pretty cool. Well, you can, but it's just, why can't I rename it? Oh, there we go. It's just that it messes up things if you just rename your scripts outright. Entity, persistent. There we go. Persistent entity data. Much more clear about what it is. Um, so let's just go here and save ourselves a little bit of time. Where are you, entity? Okay. Uh, and let's actually name this something. Class name. Persistent. One sec. Aha. See, I knew I was spelling it wrong. Um, where is it? It is persistent entity data. Okay, and we can rename this again. There we go. So, and this, oh, because I didn't save it. Save. There we go. Got me scared for a second. Okay. So, next is okay. So next is we have is player health, max mana, age, longevity. I think we had. I think we want to track also the speed and stuff, right? I think we want to track this. Maybe not so much deceleration, but definitely. Yeah, you know what? Let's track all of this. Because if we decide that we want to go real deep on stats, then at least we have it. We don't need exports. Okay. And we don't need to give these values. Okay. And I think that's all we care about for right now. We're not going to go too crazy on the stats. This is really just to get something up and running. Uh, so now we go var. So we have actually var entity ID string and give me one sec. I want to actually check because there should be some type of mechanism for GUID, but you know, we don't need to do that either, right? This really isn't something that needs to be taken care of right this moment. We have this, which is good enough. And we're not going to be making too many persistent classes. This is really just to get the player up and running with regards to persistent data. And once this system is made, then I can worry about this, and this will allow me to do other things. But regardless, we now have the persistent entity data that we were looking to make from the very get-go. So now we can go to the, let's put this down at the bottom. What is in here? Yeah, this, okay. Okay, so the persistent data manager, right? Extending node, and it's got this. So we actually probably won't need this now that I think about it, this part, because we're going to have this. Right? So we need to make something else here. So this is a save path. Uh, yeah, whatever. Um, so don't, this is I got from another YouTube guide that I was following along with. But the idea is that you want to pick, usually, I mean, I would, Unity is really nice about that they give you a default save path somewhere in people's PCs or wherever the game might be best saved. I probably want to do some reading on like a good save path. Shouldn't for these games, mainly because people on Mac, I think they probably have a different path. Most likely, they have a different path to get to wherever they need to store their saves and so on. So it would be good. It'd be good to get a good reading on what Godot developers usually use. Um, so yeah, so you see like here in the save system, Godot is a little bit different. Like first you create a file, right? I guess, or you access a file. This isn't actually making anything yet, I believe, is what I was led to believe. And then once you get here, you're just creating the data, which in this case it was something else. This is from the tutorial also. And then you turn it into a string, you stringify it. But there's a key difference, right? In Unity, as far as I remember, you can't do this with the dictionary, which is something that I would think was extremely obvious. Like, why can't you do that? Unity doesn't do that. They do it with lists, though. You can definitely put to JSON a list. I've done it tons of times, and it's very powerful. But it's like so clunky for no reason. So, but with this, you can go straight from a dictionary. It's probably just a difference in how they're handling dictionary. 99% sure that that's just what it is. And the file store line actually is what's writing it to memory. And then over here, we have something similar, but instead we're doing it the other way, which is that first we access a file on that save path, and then we say, well, if the file exists, which this also happens in, you should be using this in Unity with C# if you're not, you should be, helps. And then if not file, I would never usually do this, but this was part of the tutorial. I must have just been following along. Um, var current line is equal to, I mean, there's nothing wrong with doing this. I think this makes it very clear, but some people use it, some people don't. And if the current line, this thing actually is pretty cool, where you can just put this as a null check. All right, I'm so used to doing equals null, but this is actually like so much better. But at the same time, I find it better. But maybe somebody would like to see the not equals, or not whatever. Um. Okay, so this looks like it's good, but the thing is that um, then here it's going to want to write this stuff back to the character once it loads. But we have an extra step here. We have to write this stuff. Uh, well, actually, maybe not. So the process is we take the stuff from the dictionary because we're going to make a dictionary up here, right? And that dictionary is going to be var persistent characters for entities. That's going to be dictionary, and it's going to say equals, right? And we're going to have nothing in here for now. Actually, we're not going to make it equal to anything, right? We're just going to set that up, and then we need a method to add two persistent entities, and we need a method actually, hold on. Let's go back to this and var entity state. And this is where that enums comes in. Dot. Boy, I hate this thing. It's very annoying. Game enums, is that here? Okay. Enums entity state. Right, okay. Did I type that wrong? Oh yeah, it's just one word. Okay. So this will track if the entity is alive or dead. So the idea is that if I'm never going to be a persistent creature, should never leave, regardless of if it's alive or dead, right? We're always tracking because it's persistent. We're always tracking it. And this is cool. Like, so, like, let's say like we have like a year, we can figure out, okay, when did this character die, kind of situation, right? Based on, let's say, like a date of birth we might set up or something. Who knows? Um, so let's go back to this. So we need a method that's going to add data to the persistent entities. First, I'm getting an error. What am I getting? If, oh, okay, yeah. So we don't need this for right now. So that should get rid of that. There we go. Okay. So let's see. Func add entity. Oh, right. Func add entity, pass. Func remove. We should never be removing an entity. So that's what I was actually thinking a second ago. So we should never be removing an entity. And func change, or rather func update entity. Okay, and that should pass. And then from here, we want to add the, we want to add for something. So we need to add beta, and this is going to be of the type persistent entity. What did I name it? Yeah, it was persistent. I spelt it right here, see? I'm not a complete idiot. Entity. That's it. Okay. So this should give me access. Why is it not? All right. Let's do this. Oh, there we go. Aha, I am an idiot. Complete one. Let's go back here. There we go. All right, that should give me an error and dungeon player. Here we go. Okay, let's just save all of that and we're good now. We should be good. Why is it giving me? Could not find persistent entity. Okay, now you can find it. All right, got it. Um, okay. So now that we got spelling out of the way, good. So when we go here, go like this. Now we go back to the, actually, let's move this down here. Persistent entity needs a couple of things, right? It needs, well, it just needs one thing or two things. It needs its name, whether or not it's the player, right? So actually, it only needs this. There we go. It only needs really these two things. Let's move this up. Um, it needs these three things. There we go. No, actually, we don't need this. We only need these two. Oops. There we go. Right. Because not all entities will have a persistent ID. But if we go back to entities now, then I'm getting better at using this. That's awesome. If we go back to entities, then we'll see that this is missing something that all entities should have, which is an entity name. Okay, that should do it. So now we have the beginning of our data structure, right? So now to get this working, we can just do something like this. Well, this is going to be my first time working with a dictionary, so Unity it's a bit different. I don't know if that's if it's as easy, but we're about to figure it out. Persistent entities dot add. Guess not. All right, it's time to learn. Let's see. All right, let's. Wow. Okay. Interesting. All right, so it's a little bit longer, but all right, let's do this thing. All right, let's do this thing. Persistent data dot add. Persistent entities. All right, so the very first thing that we need to do is we need to get or we need to make a persistent entity data object. We need to make a variable that's going to store that object. It's going to just be, nothing is going to be in it. So we can say var new data is going to be equal to get the class. If I remember, this is a little bit different. Going to be equal to this dot new. Is that how it works? Okay. And then we're going to say new data dot, yep, and then we have access. Okay, awesome. Okay, so now we're just going to go, and I wish, another downside to this, you can't just have like parallel entity. There we go. You can't just have them working side. So let's just grab all of this for now. Go back to here. Go down here. Room. Boom. This. And toggle comment. Okay. So new data dot entity name going to be equal to data dot entity name. What the heck is it called? Entity name, yeah. Sure, whatever. Go here. Sure, whatever. Persistent ID. Oops. New data. Entity B is going to be equal to data dot B entity. Maybe I didn't save. Is that what the issue is? And it's not coming up. Okay, let's try it now. Persistent ID. Okay, awesome. Okay, new data dot is player equals data dot is player. Entity new data. Now, since we have that part basically on lock, let's just do this. That, okay. And we can do health. Wait, we did is player entity state going to be equal to data dot entity. Yep, there it is. State new data dot health going to be equal to data dot health. Yep. Okay. Awesome. Max. Okay, it's doing some of the stuff that an IDE should do. Now in Unity, you could also do something like a property search, and um, that would basically let you do this in kind of like a for each iteration, but or iterate through it in a for each loop. But I'm not sure if this has that, so I'm not even going to bother. It doesn't take too long to type this out. Do I have that in here? Uh, yes, it's here. I don't know. Just didn't feel like popping up, I guess. Whatever. Um, okay. I'm debating this because I'm making this so that way people can actually see this data. So if I make the max speed something that people can just change in the files, that might not be good. They'll easily be able to break their game by flying through terrain by setting their speed to like 99999 or so I'm debating if this should even be shown. Because I'm not going to encrypt anything here. There's no reason to encrypt that. I don't like the idea of doing encryption. If people want to change the data, they can change data, but I would like them not to absolutely break their games. That would be as funny as that is to me. Maybe yeah, I'll just leave it. People if they want to break their game, they break their game. That's fine by me. So then the next thing is, they say some people just want to watch the world burn. um, so the next thing is we just go to persistent entities, and so this is the thing, right? Like, how do we add this to the dictionary? I know how to create the dictionary, obviously, but how do we just add it to a dictionary? There would seem to be no add functionality here. Let's see. To add a key to an existing dictionary, access it like you access it like an existing key, assign it to it. So, oh, okay. Okay, so basically you just write in the key, but then the equal sign will come off as adding. All right, let's give that a shot. See if that's a thing. Um, First we want to do a check on it though, I think. Yeah, let's do that. So the first thing is we want to check if then return. We don't need to go forward if there is no persistent ID on this thing. If there is, then we do we go equals to new data. Right, that should be it. Pretty simple. So this is going to now, whenever we add an entity, it should just add it to this, right? And then now if we want to update an entity, yeah, if we want to update an entity, then this is this should be kind of like, instead of having to save the game, we just update the persistent entities, right? Which is a lot less clunky if the game gets very expansive. Like, let's say we have 10,000 entities or whatever. We don't need to save 10,000 entities. We just need to save the entities that want to be updated. And then when we go to actually save the game or load the game, then we're doing all 10,000. This is kind of like a Fox save to prevent the need to actually have to save. All right. And I think that should be very good. I think that's a good mechanism to have. So it's not actually going to take as long to type once we got that part done. We can just copy paste a lot of it. So it's just basically the same thing. First, we do a check to see if it has a ID. If it does, then we're also going to do a check to see if we need to check to see if persistent entities dot find key data dot persistent ID. Right? So we need to check to see if it has that, and then if it does not have that, and if it doesn't, then we return. And, or rather, if it doesn't, then we run add entity, and we pass in the data, right? And then we return. And then we say, same thing, which is basically, if none of this is true, right, we just need to pass this back in again. Now, here's the thing, right? If I'm curious, let's go back to the dictionary. No, we're not doing all of that. Nope. Um, I think it's the same thing. I think it's actually, I think, I think it's the same thing. I'm pretty sure it's the same thing. All right, so let's actually go back. I think we can get away with simply just I think we can get away with doing simply the same thing. Almost 100% sure of this. So yeah, so basically this is just taking the data from wherever it exists inside of the persistent entity. And it would be nice if we could just, like throw in the persistent entity data, but the reality is that some of these data pieces or properties are in different areas. So some of them are entity data, some of them are persistent entity data, but we want to store all of it in a persistent. So we actually needed to make a new class for that entirely, which is what we did. And then we just stored it in here. So it looks like as if GDScript goes and does our job for us with regards to doing a check to see if this. So we actually don't need this, right? And we can just get away with doing that, which is oddly enough, the same thing. We're just basically doing the same thing over here. So we can do update entry, and it would effectively be doing what we had wanted to do from the very get-go. This just makes it clearer what we're doing, I guess. But yeah, it's effectively updating the entry is effectively adding. It's the same exact process. because of just the nature of how this works, right? This apparently it's going to either add or replace um, previous data in this. So now the next thing I think what we need from this is we need to now that I think about it, maybe this needs to do a check to see if the entity. No, we don't need to do a check. We're just making things more complicated for no reason. Um, all right. So the next thing that we need to do is we need to actually read from our persistent entities. We need to get that information that we've been putting in there back out of it, right? So we need to pass in. It's basically going to be returning the um the persistent entity data, right? Whatever the method is that we're going to be making. So let's do that. Func get entity, and we're going to be passing in. This is the part that gets hard because I don't know what is going to be the requirement to identify things, right? We have the ID, sure, but that ID exists really as just a way to have the key be unique, right? It doesn't exist as a method of actually um, identifying in the game itself, or rather the element. It would be nice if we could do that, but I'm not sure if GDScript has methods that could allow me to create that architecture um, easily. I'm pretty sure it does. I just don't know. So what I can do is uh, I can work around this by using the scenes in GDScript. Yeah. So if we go back here, right, and this is better actually just having this in one place rather than having it in multiple places and have to update it multiple times. I like this, I'll be honest. So var current location, right? And this is going to be scene of type. I don't know. What is actually, I guess it's a node? No. Tree? Yes, no. Node 2D, I guess. Current location, node 2D, right? So in the persistent characters, we're going to go back here real quick. Persistent entity. And we're going to add var current location node 2D. Right, so this is tracking the current scene of this particular persistent entity. And then we're going to use the current location to determine if I mean, we're doing a few things. So let's just actually, instead of me explaining it, let me just do it and show you. So we're going to do get entity, and we're going to be passing in, we're going to be passing in location, and that's going to be node. Oh, oops. Node 2D. And we're going to be passing in we're going to be passing in its current location, and we're going to be passing in a bool is player bool. Okay, So now if we're going to do a check first on, oh yeah, and it needs to return the, persistent data entity data. Okay. And we want to check first. Oh, wait, no. We don't need this. What we need is, sounds a little bit weird. Sounds a little bit weird, but actually what we need is the class itself, right? Let me check something. No, that doesn't help because more than likely it's going to be a unique instance of that node. So instead, that would be running in a circle down a drain. So instead, what we're going to do is we're going to do a check to see, or no, actually, we're going to collect first and then do a check on the data. Yeah. Okay. And then we're going to go here and we're going to say, okay, if data is, no, data dot is player, then we're going to do something else. So if the data is player, then, oh, oops. If the data is the player, then we will go to do a check if oh, we actually should do something like this also, so that way we don't get multiple. So first we need to find out if this thing actually contains, which it should, but we want to check first if if persistent entities dot contain has key find key no. So first we need the key. Right? And the key is the persistent data ID. So we actually don't need to do this. We actually need to create a hash, I believe is what we need to do. And we need to iterate through the dictionary. And then for each item in the dictionary, then so this is a matter of being extremely counterintuitive to how dictionaries should be working, at least from what I understand of them, right? And a lot of this comes back down to just sloppy architecture on what I just did. That's sloppy. Nothing is coming to mind on exactly how I should be approaching this. Hmm. I'm not drawing blanks. It's just so weird. It really is a little annoying. Um, okay. Okay. I think um we have a very expensive call in the make here for no reason. And I think part of that has to deal with what we just decided to do. And the solution is the persistent ID needs to go. Instead, the key should be the location because that's what we're using to get. I just got so tied in or invested in the persistent ID that it never crossed my mind because that's what I would normally do in Unity. That's not what's going to work here, right? In this structure, as I'm setting it up, the get is kind of narrating how the add should have worked. So when we go here, instead of doing this, so let's go here and we can say data. First, let's save. Wait, I'm getting an error for some this. Okay. So let's go take a step back and I guess we can keep persistent ID. Maybe in game we can use something for this. Like I can understand that, like, let's say we have NPCs that are trading specific items and they have other things in common. At least they'll have a unique ID for them, right? Persistent unique ID. So that's going to be something that I want to keep. But I think what we're going to do is instead of storing, I want to see. Uh, this isn't tied into anything, I think. Let me do return. Oh, should be fine, right? Okay, good. Um, I want to test that out. I want to find out before I try to implement it. I want to see what happens if I do that. Let's go. Where is the player? Dungeon player. In the process, I want to print. Well, first I need to. So the level test is over here, and this node, node 2D, is called level. So on ready, shouldn't it be? Oh, there it is. Okay. So we want to get the current location to be equal to get node. No, we don't want that. Hmm. Like I know how to get to the level, obviously, right? That's not really problematic at all. Not at all. The issue is I want to get to them dynamically. So how do I tell it to go up one level? Is there like a get parent kind of thing. Oh, right. Okay, that's nice. Current location is equal to get parent, and then I'm going to print current location dot name. All right. This shouldn't give me any errors. Let's save. Not getting anything back. Let's go. Level. Awesome. Okay. Awesome. 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 So this comes with an upside and a downside. This comes as an upside and a downside. The upside is we got that. The downside is it doesn't matter. There's a problem because we could accidentally name these things the same thing, right? So what we actually want is we want its file location because you can't have the same things with the same names in the same file. It'll that just doesn't work. So we would rather have the file location parent dot get file. Oh. Hold on. Okay. I think I got something. Is that a thing? Uh, it's actually giving me an error saying get seen as not found. Hmm. Um, current location. So, is that a thing? And I don't think so either. Ah, oh, the pleasures of Godot. I'm going to take a small break. Be right back, though. Okay, there you go. Took a second, but I figured it out. It's always going to be as simple at the very end, but figuring it out, you just need to go through a few hoops to get things done. But this is good. All right, so this is exactly what I was looking for. So the idea is that later on, so for later on, I'm going to be doing some type of architecture where there's going to be something like you see how right now in the hierarchy the player is simply just out and about underneath the world, but that's just not good organization, right? So I'm probably going to end up with something that's homing the player. All right, so basically it's going to be responsible for the level of start up, and then on its ready it's going to figure out where to add the player. It's basically going to manage the player, and then also that is going to be something that is going to be unique to each level. So I just need to make one player and it'll handle how that level wants to handle that player rather than me having to put that in a player script itself, right? Um and so all I need to do here is to get the parent because this is going to be the parent of the player at that point and get its file path, and it should be the same file path as the top level here. And once it does that, then it should give me back this thing down here, which is the correct current level that we're in. Anyway, now that this is a string, and it's a string that I don't care about, like these types of strings I do not mind, right? This can still give me problems though. So like let's say later on I change the name of this from level test to test level. Then it would have been stored in the dictionary, right? So now we're going to have to create, let's go back to the dictionary actually. So now that we have this done, I'm going to just do this. I'm going to leave this the way it is so I can just see it for now. But yeah, so let's close this. Close, close, close. We learned a lot. Well, at least I did. I didn't really talk much, but I learned quite a bit there. Okay. So we're going to say that this is actually going to take in the current location. So the data dot current location as its key, right? Um, as its key. And I don't like this actually because we can have multiple persisting characters in the current location. So technically what I should be doing is making an array inside of that current location of all of the persistent characters. That's technically what should be happening. But I'm not sure if I want to do that. So instead, so we need something. This is already good, but we need something that is really good. This is why I wanted to use the unique ID, but there's an unfortunate circumstance tied to that. So another element that could be possibly be unique to persistent characters in Godot. I don't know. What could possibly be unique? I don't know. Can't. No. This is really just about um, setting up unique data. That's really what it comes down to because I'm getting caught up in this idea of future proofing it. But I'm having a really hard time because I don't know how Godot handles its internal identification numbers. Like in Unity, uh, the numbers will change based on um, when you're running, right? So you need to find like a persistent number. So to set that up, the process would be something like you create it, and then from there on, you're just saving and loading it. The problem is, so my original idea is that I was going to save using the key being the persistent data, right? So let's start from start to finish on this. The character doesn't have a persistent any type of persistent information on it, right? So instead, when the game starts, we load. And then when we load, we're going to try to find out, well, what scene are we in? And then we're just going to populate a bunch of characters in that scene uh, that we find. And we're going to say, hey, all of you guys that are in this current scene that the game loaded in, you guys have this information, right? And none of them really existed before. They all were just given a persistent ID and so on. For that session, they have an ID. So the instigator of the uh, setting up the scene is then the manager here, the persistent data manager here, which is okay, right? That's fine. When the scene starts, the persistent data manager is going to go through its thing and say all of these characters that are inside of this current location. So we're left with this situation now where what if the character doesn't have an ID? So the game, let's say the player is starting the game for the very, very first time. The game is going to run through a bunch of add entity calls, right? It's going to create one for the player and then create a whole bunch for a whole bunch of NPCs. Let's say we set it to 1,000. So it's going to be 1,001. And it's going to just set up all of that data. It's a massive thing, right? It's huge. But most of it is actually done. We have something here that's tracking for if this is the player, but technically, if we're going to do it that way, I don't think we need to do that. We can. So I think this is just a matter of that we kind of jumped ahead of the horse, right? We need to actually do an initializer. We need to do an initializer for at least the persistent data. And so when the oh yeah, let's name this class name. There we go. And so when the player starts the game, right, we're going to do a load. Oh gosh. We're going to do a load. And when we load from here, it would populate this. But we need something to do a quick check. Is after this loads, after it runs a load, is this empty? If it's empty, then when the player clicks new game, it'll run the populate and populate the game based on that. Right? Right. And then we can go from there and treat the player differently. So let's start with this. Pool. Whoops. Okay. So basically, if the game is fresh, if we have a person just bought the game, turn it on, there's no saves or anything like that, then the persistent data manager, no, this is problematic. Uh, yeah. So I think the way we did it before was good. So if we go here and we say, oh, we already actually do it here, right? So this is happening when we click new game or start game, whatever. We'll try to do a load. Oops. When we do a load, we'll say, hey, give me access to the save path. And then from there, it will say, okay, start game, load. There's nothing here. And exists. File doesn't exist. If not, end of file reached. Okay, so we need to go back to here. Get out of this. Oops. And we need to say else. And then we need to do something like populate. Persistent entities. Okay, good. So now when we go here, we say something like populate existent entity. Oh, sorry, persistent entities. Okay, and this will be responsible for just this doesn't have any actual data, so it's not going to load any data. But what it will do is it will create all of this data, and then it's going to create an initial save file for it. And then once that's done, then inside of each character, they'll have their own initialization, right? So like some characters will be stronger than others and so on and so forth. Player starts with their base stats, but that's handled at the character level. This is just supposed to be handling the data, setting up this data structure. For this, the initial setup is we're going to just run, let's say, here we can go var character or entity count is going to be equal to 1 for now. And that 1 is going to be the player. And we're going to say, oh shoot, I have not done this ever. Son of a gun. There's a couple of things. We don't need to do this anymore, right? We can actually go back to doing this. Data.persistent ID. Okay, boom. And the next thing is we need to create a whole bunch of these persistent entities, right? And we need to populate those. Well, we don't need to populate it with anything. We just need to give it persistent IDs. And then push those in. That's the idea. But it needs to be in a controllable way, which is something I think get entity will have to handle. Right? We need to get a method of getting a particular entity and I think we can use this now. We don't need the location. We can use, well, it would be nice if we could use the location, but we can actually just use the ID. So, ID string. Now, for something like this, I don't mind string again because I don't really know or care what this is. Like once this is made, it's set in stone. So all I'll ever be dealing with is variables. I don't actually have. I mean, if I opened up the character data, I could manipulate the string itself, but I don't actually have any control over whatever value this is going to be. Right? I can't accidentally change it. Um. Okay. So with that said, populate persistent entities. So first I need to do this, which is I need to make a var data, which is going to be equal to, um, where is it? It's persistent entity. Oh, wait, no. We go for, I gotta look. Do they tell me how here? Nope. Okay. Hold on. I need to double check something really quick. Have not used a for loop, I think, at all. So that's what it looks like. Okay. All right. So let's go here. For entity count. Does that work? Hey! There's no quick links leading to any tutorial on it, so that sucks. But that should work. So this should just go through once. So for every I in entity count, which it's at 1, let's make this an int. There we go. For each I in entity count, we're going to say that we're going to make this. We're going to do hmm. Interesting. Okay, I got an idea. It's kind of, I don't like it, but it makes sense. So let's do like this. Var timestamp is equal to OS. This is one of those OS classes that I was looking at yesterday. Um, I don't know if this works still because Unity, Godot things. Um, sure. And then I think this is one word. Okay. And then we do var. Okay. So that should give us our unique ID for each one, right? And then from there, yeah, and then from there, we can do this. Hmm. Hmm. uh, this is actually interesting stuff, right? So in this case, this should actually be removed. And boom. And this is where this should go. And then over here, oops. Let's get out. Yeah, that's fine. That's good. Okay. And then over here, we just want to do hey, there you go. So now that should be okay. What's this? Property with inline code must be an indented block. Oh, there we go. Okay, and then what's this one now? Identifier data not declared in the current. What? Oh, ID. Okay. Uh, is there some? But this is where it starts to get a little annoying, because I don't know what operating system. Hmm. Let me see the docs show any way of getting time. The time singleton. So it's get Unix time. So I think they put it into the time system. Is that what it is? So get time string from system. String get date string from Unix time. So how do we call this? I'm sorry, you're not seeing this. Let me see if I type it in here, will it show up? This is supposed to be time dot get get date, no, get string from, no, get string from Unix time. Nope. Get all right, you know what? I'll put it in and then I'll hit control and we'll see what it does. Get time zone from system. Get time string from system. Returns the current time as an ISO. Don't want that. Get Unix time from, nope. Okay, returns the current. Oh, I see. Okay. So this is what I'm looking for. Get datetime string from system. Returns the current datetime. Okay. So this is what I'm looking for. Grr. Highlight it. There you go. Okay. Is that a thing? Is that how it's supposed to be? I'm pretty sure that's not supposed to be. Get date time string from system. Get date time string from system. Yep, there we go. That's much makes more sense. Um, okay. That should be it now. Pretty sure. I think time is a singleton class, so I should be able to just get it without having to like instantiate it or anything like that. I think. Actually, let me see if there's a check, an example how this stuff is called. Nope. You just gotta figure it out. I mean, I'm assuming we can call it as a static function. I'm assuming. Is it a static function? Let's do a check. F static. Is this a static class? I don't see. I see zero matches. So I'm going to assume this isn't a static class, but we're going to act like it is until this thing tells us it isn't. We're going to do a quick test on it also. Where is it? Yeah, we're just going to do a quick test on this. So this is persistent data manager is not really accessible from anything, right? It's in our data class. So we're going to just go to the project settings, auto load, and can we just drag it in as a persistent data entity? We're looking for the manager. Nope. Okay, so we have to go here. Scripts, managers. Okay, add it. There we go. So we're just going to go here real quick and test this thing out. It would be, I'm just going to call this populate. And yeah, close. Just going to call pop. Oh, wait, forgot to do this. So then we just do print unique ID. Actually, and also we want you to print persistent entities dot count. Did they have something like that? Blank. Um, okay, hold on. Unique ID. Yeah, there we go. So it should print it twice, right? The first time is going to be the unique ID itself, and the second time is going to be the unique ID in the dictionary as the key. Well, let's get that, and we're going to say dot entity, yeah, entity ID. Okay, that should do it. Okay, so now we go to the player, and instead of doing this, which is cool, this is nice to have, we're going to do this. And it's going to be, sorry, it's going to be part of this. Right. Sorry. It's going to be, Okay, test this thing out to see how I'm expecting errors. Yep, there we go. Um, yeah, it was an error over here. So let's just get rid of this for now. Come back to it in a second. Because I expected I do not know how to access these dictionaries. And there we have it. This is the unique ID. Oh, okay. So we know that it's making the unique ID. Now, what I want to find out is if it is adding the unique ID to the entities list or dictionary. So we can get rid of this now. We know that part works. Now this part, dictionary. Let's check that out one more time. Is there any way to check the length of the dictionary, or how do you read the dictionary? That's a good question. Let's find out. Are you serious? No way. There has to be a length. Size. Okay, there we go. I mean, yeah. Okay. All right. So where are you? No. Here we go. The very first thing is size. We want to know what the size is before and what the size is after. Okay. Save. Print. Yep, it added it. Okay. So we know that it's adding it to it, which is very nice. Now we need to get access to it. So we need to actually call a get this part. So for now, this is returning null, but in fact, what I want it to do is I want it to take in the ID and return persistent. No, if yeah, Unity is a little bit different with this, right? Because you can just use something like try get, and I love using try get. It's freaking awesome, but they don't have that here. So we can use if um like try get is a specific dictionary. Check. If persistent entities dot as key find key data, or rather ID. So we don't actually need this anymore. Just awesome stuff. Right, we're getting more refined as we go along. Return uh persistent else return So if we say, hey, we want to get an entity, and we don't have that entity ID that we put in, then what we want to do is we want to go through a couple steps. First, we want to uh, func generate ID, which is going to return a string. And I'm going to take this. Okay, there. So if we go in and we don't find, or we find something, then we're just going to return what we found. If we otherwise, we are going to create a new ID, add that entity, and then spit out the entity that we found, right? So in this way now, we have two ways of initializing things, right? We have this way and we have this way. This way is kind of, I'm imagining doing this like at the very beginning of the game, right? Actually, we can get rid of this stuff, cluttering it up now. So we could do this at the very beginning of the game. And it'll just iterate through all of the stuff and then say, hey, everything you now exist. This is your ID. And then we have this one, which can happen at runtime. Well, I mean, it's all runtime, but while the game is being played. So, if, like, let's say we want to create a new NPC. Let's say an NPC is born or something like that into the world, age 0. We can do get entity and see if any entity already has an ID. So if we put in nothing in here, right? So we want this. Yeah, there we go. So we want this if ID, if not ID. No. So if you put nothing in here, then return null. That's the idea. All right, you're going to get a null. No, actually, if you put nothing in here, no. If you put nothing in here, then it should do what it's doing now, which is and. So if you put in, there's two conditions here. First, the ID exists in it, and the ID is not um, something that is null, right? Or it's not blank, in other words. It's not, I don't know how this is going to handle strings with that are blank, but are not null. But I'm hoping that it's built in for that. We'll find out. But the idea is that this should always have something, right? It should always have some values or some length to it. The new ID is going to be created, and then we add that entity. So a child is born into the world, and then we return that entity, and then we can do whatever we want now with that persistent entity data. Right? It's going to return that persistent entity data. I think this is done. I think this is pretty much finished. As far as this section goes, I think we have the interaction that we wanted. So now I can just change this to like 1000 and it'll create 1000 characters essentially. Obviously they don't have like, we need to make something like a name generator and stuff like that down the road. But right now, this is what was needed. Right. So we have to have like this, the rest of the stuff, like what the initial health is and so on, that's going to be handled inside of the entity itself, right? It's going to have that already. So let's go here one sec. Okay, there we go. So this will basically, uh, if this is, let's say there's only 999 and you have 1000 that's allowed, then this will just create one rather than creating 1999 characters. Very simple stuff. What else? I think that's it. This is just checking if we want to update the entity and for some reason the ID is null, then where there's nothing in the ID, then we don't do anything. As far as adding the new entity goes, we do that here. Right? And this makes more sense. This makes a lot more sense. Generate an ID. It's here. We populate persistent entities. Yeah, I think we're good. I think that's it. I think that's it. I think we're solid here. So let's take a look at the task. Um, Set up the play data file. Yeah, that was basically it. We have the save load system at the bottom, but it's not integrated yet. So let's integrate the two, and then once we finish integrating that, I think we can throw this into the done section. Script. So the next step is, there's two more steps that should be attached to this, right? There is this part, which is going to be just integrating this, which is fairly simple. It's just this, right? It's just we delete this. Wait, I think it might be more complicated than I originally imagined. I don't know how JSON treats classes. Even though the class only has properties in it, in Unity, what you do is you just serialize them, and then you put the class in, and it would take only the serialized data out. But I don't know anything about how Godot is going to treat this. But there's only one way to find out. Um, we delete this stuff. We go here, and we say this is going to be the persistent entities. Okay, and this, the goal of this is to write back to persistent entities, right? So the idea is that we did find something, so now we just need to repopulate persistent entities. We don't need to, like in this example, we were populating a class with the data from the current line. But in truth, I think we can just take in truth, we can just take, if I understand the context of what current line is, it's not iterating through. If not, and blah, 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 current line, get line. Like, I don't know what this is doing exactly. Can I figure that out? Let's see. Get line. Return is the next line in the file as a string. Text is interpreted as being. Sure. Close. Still don't understand. I get what parse string is supposed to do. But is it saying that it's getting the line in the file? Because here it is. These are multiple lines. This is one line. This is another line in the file. So it reads off to me as that. And this is not iterating through anything. So what is current line exactly? I'm thinking current line. What is it returning? That's the question. So what is parse string returning? Parse string is returning a variant. Well, screw you too. Ha ha ha. You're funny. So variant means it can return whatever it wants to return. In this case, it looks like it's trying to return looks like it's trying to return a dictionary. I mean, that's what this current line, this format looks like. This get line is returning a string. All right. There's only really one way to figure this mess out. That is to do it. So let's go here. We're going to shift this down. And we're going to, so this is going to be in this part, save game bin. So we're going to do if current line, and we're going to say persistent entities is going to be equal to current line. Will you let me do that? Looks like he's going to let me do it. Hmm. Hmm. I'm so confused, right? Let's knock down the things or jot down the things that I'm confused about. Right? So confusion one. So confusion one is how it's storing this information in JSON. Because originally, the way that it's supposed to be is that it's stored as the item. But it's stored the data when you stringify it, it stringifies the whole dictionary. So when you're taking it back, and then the file takes it back from being a dictionary. In other words, JSON itself is storing the information in a format that's being translated to a dictionary or requires a dictionary first. Right? It understands, maybe it doesn't require, maybe it understands when it's a dictionary and it'll parse it that. Logically, it makes sense that it would, because the format just makes sense that way, right? If you look at it, it's saying current line and then it has the brackets and it's acting like as if it's a dictionary or that I'm reading it from a dictionary. So if I just simply do an equal, right, between the two, then it should be going from dictionary to dictionary, essentially, is what I'm thinking. It looks like it's a dictionary. It acts like it's a dictionary. It probably is a dictionary. And there's only one way to find out. So let's do that. So we're going to get rid of this for now. I don't think we need it anymore. We're either right or wrong on this. If we're wrong, we'll just have to work our way around it. Hopefully we're right. If we're right, then by gum, I think that Godot is probably way better than, at least for saving, is way better than Unity. Like, incredibly. Because this is just super convenient. If this is actually, like, I guess what's happening is that I know that it shouldn't be this easy. I'm like trying to figure out where's the trick. Like, that's probably what's happening. I'm like, what the hell? This cannot be this easy. There's only one way to really find out exactly how this is. So let's make a quick function to test save load. So this function is going to operate in two steps. First, func test save load and load. Okay, and it's going to say, first we're going to save the game. Okay, so first we want to well, actually, no. First, we want to generate or get an entity because I want to test get entity out also. So get entity, and we're going to leave this as nothing, right? So by default, it should be creating a new entity. Okay. And then we're going to go here and we're going to just test out that. So we're going to print it is persistent entities.size. Okay. And that's going to be part A. Then part B, we're going to then do a save if, persistent entities.size is greater than 0. Then we will do the next part, which is save game. Okay. So then we do save game, and then we do a print. And we're gonna do just a note saying game save. All right, this should just let us know that it did attempt to save the game. We didn't get an NT0. So in other words, this is just like visually to let me know that these steps are happening right now. And then if, wait, no. Then we say load game. Wait, no, that's not what it was. Now we have to go if file access. Just do this. So there we go. Okay, and so now it'll tell me, hey, yeah, there's something that was saved, right? And so now we say, well, yeah, let's actually do it here. And we can say load game. Okay. Print. Well, actually, yeah. So, yeah. Okay. I have, you have this. The load game isn't going to be really beneficial to examine here, but we're going to do it anyway. Game loaded, just to see if it's going to throw us an error. It might. Again, I don't know if this works. We're about to find that out. So let's just go to the player and then on ready. Where is it? Dungeon player. And then just do a quick test and find out, hey, are you actually... Yep, something went wrong. What is this? Return. What is it saying? Invalid get index of type string on base dictionary. Why? Money? Ah. Okay, invalid get index type string. It should do add entity. And add entity. So we went to here. Basically, it's saying, yeah, we did the get and there was nothing here. We need to generate a new ID. And then we're going to take that new ID and then add the entity to our thing. So then when we go here, we do add entity, we do this part. I think we need some iteration through the we need some iteration. I need to see all of the keys on this this thing, on this dictionary. I need to iterate the dictionary. So before we even can do all of this, right? Let's just do it like this. We're gonna go here, and I'm gonna do this real quick. And I want C for I in, I think this is what format was, right? For in I in, yeah, okay. For I in persistent entities dot size. I think we can just do persistent entity size, if I remember correctly. Yep, we can. For I in persistent entities, I dot key. Print I. Okay, that should do it. Let's try it one more time. What the heck? What is it doing? Get entity. Oh, it's this part that's giving the issue. Yeah, that was my fault. So, or was it? Oh, that wasn't a fault. That was just that. Okay. So let's do this. We're going to take this, we're going to copy it, paste it over here, and then we're going to just go here, and we're going to go like this. Um, and then we just do return null. Okay. And over here, we're not expecting anything anymore. We're just doing that. Okay, good. So let's try it now. Okay, so now it's saying what? New ID is not declared in the current scope. Right. This part. There we go. Didn't do it. It didn't. Well, I mean, it's working. It's just that it's add entity. Where is it? It's supposed to print this. So for I in. Right. Okay. So we got to do this first, then go here. And then we say, oh, let's try it. Okay. It's there. It shows up. Um, okay. Let's try this. I dot, oh, oops, how do we read this? Error. I dot, this is so weird, right? Because it should be iterating through this. So this is the key for each key. So it's reading the keys properly. All right, let's do it like this. I dot entity ID. Let's type it in and see if it picks up on it. Nope, crashed. Okay. Entity ID. Invalid get index entity ID. It did not work as in I thought it would. What I mean to say is you need to apparently identify the individual properties of a class. You can't simply just store the class and it serializes the properties on its own. Or maybe you can. Hold on. Let's check with the document. Um, huh, yeah. Hmm. It's saying that you can do it. When you load, you obviously have to, you know, soft clone the data, but when you save, it should be able to just take it from the file, right? That's what I'm reading. So save to JSON data to file, just file new, store string JSON data. I'm going to try it one more time, but I'll show you what I got out of it. Actually, hold on. Let me do it this way. That way we can guarantee whether or not it's working or not. Also, the other error that I was bumping into was a typo. So there's that. And it disappeared. Where did it disappear to? I don't know. It's weird. Where's OBS? There he is. Want to go here and there it is. Save game. Here we go. Yeah. So it was storing the key properly, right? This is the key for this character, but then the actual data, like this should not look like this, right? So I have questions, and I don't think it's going to be a simple answer. My question is this dictionary going to have to take another dictionary? And this dictionary would basically be the property and the value. That's what I'm thinking has to be done, which isn't too bad. It's a level that I didn't think that I wanted to get into, but I get it. I think I get that. That's what has to happen. Okay. Okay. I understand. I understand. I understand now. Okay. So long story short, I think what needs to be done is I need to make a nested dictionary. Right? I believe what needs to happen is that this dictionary is going to have to take in um, a new dictionary. So in other words, see this new data class that I made here is moot. You can't, this is a Unity way of handling this. This isn't a Godot way of handling this, right? And that's fine. Absolutely fine, right? It makes some sense. Hmm. But I mean, there's winning. There's some wins and losses that happen with this. First off, I am not going to store the key for these as a string. These are known data. The other ones, like the ID, is an unknown element. It's just a variable to me on the screen. But this is a known element, right? I know what the name of health is going to be: max health, mana, so on, so forth. So if I go over to my, get rid of this, close game enums, I think I already have some of that right over here. So the idea is fairly simple, sort of. Right? The idea is fairly simple, which is we're going to store a dictionary that holds key. In Unity, keys are going to be of one type. Right? We don't have keys of different types. I don't know if that's the same thing in Godot because it's dynamic in and of itself. So maybe it can hold different types. You can probably read about that in the dictionary section or find that out the painful way. So let's do that. Let's do it the painful way. Why not? Okay, so this was a flop of an idea. In Unity, this would have worked, right? We just make the class and the class stores the data. This isn't going to do that. In fact, it dislikes doing that. So sad. Because in Unity, what would have happened is when we went to save this, it would have parsed the properties of this and said, yeah, this has all of these properties. Let's take that and assign those values. Yes, right. Didn't do that. So we're going to make a new dictionary. We're going to actually just get rid of all of this now. Right, that. Toggle that. Okay. And we're going to say, we're only doing this really because it'll help down the road, but you'll see what I mean. So we're going to say, var new data is going to be equal to dictionary, right? And then we can say, enums dot health, say, and I believe it's like this, and then it's data dot entity, or sorry, data dot health, right? And then we go like that. I think that's how that's supposed to be set up. Am I right? I think I'm right. Pretty sure I'm right. It's just telling me I'm wrong. It's just telling me I'm wrong, but I'm pretty sure I'm right. I just need to do this. Let me see. Quick way to find out. Hmm. Mm-hmm. Yeah, I'm doing it right, I think. Let's try it this way. Is that going to fix it? Oh, I'm a dummy. Okay, we got it. That There we go. That should work. Let's see. What am I missing here? Something. I think we have to do like that. Okay, now we got it. Okay, so now it's saying you can't find health in enums. Enums, health. Oh, stat. Dungeon player, dungeon manager. Okay, does that work? And it works. All right, we have a pattern. Nice. So we can do something like enums dot um entity property name equal to data dot entity name. Now a lot of this stuff I have to make later on, but for right now, I'm gonna go with whoops, like that. And then we're just gonna go the ID is going to be equal to data dot persistent ID. This is evolving. Yeah, this is just how I don't know if it's the right way to handle it, but this is the way I usually handle it, apparently. I don't think we need to know if it is player anymore because we have the persistent ID set up properly. And we need to know the entity state. I think we already have, yeah, enums dot entity state, yeah, dot, oops, we have an issue here. I don't know if I'm going to do the entire thing, though. Just because I want to test it before I commit to it. Okay, so let's just call it there. We'll go over here. We need to create entity properties. Enum. I'm doing this for a reason because I'm anticipating that it's going to throw exceptions because of the different enum types that are thrown into that single dictionary as its keys. So worst comes to worst, we can just have the properties hold everything. So it's property.name and ID. where are you, game enums? Okay, that should do it. That should fix that, right? And then what's happening over here? 0 as already used in the dictionary. Oh. Oh. Okay. Yeah. All right. I got you. It looks like we're gonna have to use it for different reasons. So yeah, looks like we're gonna have to do it for different reasons. But it's fine. This is fine. This is okay. All right. Bam. 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 Basically, but the thing with enums is that they're actually numbers. So going from like 0, 1, 2, 3, they have numbers within them. I was hoping that it would stringify them, but it's reading them as a number. So it is what it is. It's fine. State. Oh, max. Okay, there we go. And now we go back over to the enums, and we can just add it as state health max. Okay. And you know, might as well we just add the rest if that's the case. Yeah. That's the beauty of having all of this in one area, I guess. One of the beauties. Yeah, so later on we'll add the rest, but we want to check to see if this is even going to work. There we go. Next, we want, so we set up the dictionary. The dictionary is going to take those things in. Then we go over here and we say persistent entities. And we're going to go with a data persistent ID. And we're going to say is equal to new data. Right? That's going to be it. So now, well, now that we've established that this is going to be how it's set up, this further establishes how this is set up. Right? So this is kind of like my mock, and then this is going to be the actual. So over here in the actual, what we do is we go here. This is what we're doing the test. And we add an entity. So first off, we don't need this anymore. This garbage. Instead, what we have is new data. And we're going to go here like that. And we're just going to grab this. And that's it. So that should be the trick right there. So next we need to figure out, okay, so now it should add the new data ID that we get over here. What's it saying is the issue? Identifier data not declared in the current data. Right. Okay, so this is just ID. Right? Okay. So I think that's it. Now we can test this. It should add this ID, and it should store this, I believe, as number 2. Name ID state, yeah. I believe it's going to store this as number 2. Right? Or, sorry, this is going to be number 1. So let's I have nothing else writing. I don't think there's anything else that's supposed to be writing. And I want to leave it as that. So let's play. And we got an error. Okay, dictionary. What is this? I see. Right, this thing. So we want this to return instead. The dictionary. Right? And let's see if that works now. Save. Yeah, okay, good. All right, so now that's returning the dictionary. Let's check the file itself and see what's in it. All right, it worked. Let me share that. Here we go. This is it. It's storing the key here, and element 1, like I said, is stored here as also the same key, right? So it has access to it in 2 ways. Awesome. Awesome, 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 awesome. So now let's fill it out a little bit so you can see more or less what where is it? There it is. Okay. More or less what's going to happen. So this is when it adds a new entity. So we're going to actually do the, where is it? Over here, we're going to do update entity, an update entity call on it. But let's fill out the rest of this first. And after we do that, took a little bit. And we struggled, but we got there. Enum.entity property dot mana. And we can say data dot mana. Yeah. Oops. And enums entity. No, let's just grab this like this. And we can say max mana. And then we can go here. We can say basically the same stuff. Age data dot age. Right? And so now the best part about this is I can make a specific reference using the enum. And because the enum, like if I just want to know the name, the ID, the state, blah, 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 I don't have to worry about whether it's caps lock or not. That's basically it. It's not case. It should fill it out on its own. All right. Or I can just go in somewhere and check. Age, longevity. I don't know what the heck is going on. It's expecting. Well, oh, that's what's going on. Do I don't think. I think we decided that deceleration at speed and acceleration should be there. So let's just I'm gonna put them in. Oops. Okay, that should be it. Deceleration. Yes. Did I type it wrong? Deceleration. See, I typed it fine. What's going on? Ah, just took a second. Okay. Um, and then we write that to data. So, boom. Okay, that is from the test, that was working fine. So now the data structure is fine. It's working. We just did the test. Save and load is working. And it's saving and loading it properly. It's doing what it should be doing. So this is going to become a massive behemoth of a freaking thing, update entity, right? It really is, because we're going to basically be grabbing the data from the entity and, well, at the same time, we're only updating a specific entity. So this saves us. This is, even though this is a very big function at the end, it's actually very light when you compare it to something that's going to be like this, right? Because we could have like a ton of these and it's going to be problematic. Well, not problematic. It's not bad because it only happens once, but still, it's a big call by comparison. Um, yeah, and it gets called here. Okay, so we now know we have save, load. It's everything is happening properly. Um, actually, we don't know if everything's happening properly because we're missing the data, right? So the easiest way to find out is to first save the game, then call this um, persistent entities, then clear it, and then when we load the game, then we say persistent enemy. We go print persistent entities. Um, we need the no, actually we can just do it this way. For I in persistent entities. Okay. And we can just say persistent entities I or print persistent enemies I dot um I think that's it. Right? Pretty sure. Uh let's double check something real quick. All right, and we'll let GPT run with that one for a second. And we're going to go back over here and we're going to say dictionaries also. So let's just check the documentation out. And nested. Dictionary. Nest. Oh, whoops. I see. There we go. Okay, so let's find out. Make read-only nested. Nested dictionaries. Here we go. Nope. Oh, you can. It shows it right here. So basically in this one, we have, this is so weird. So you use a string and then they have an integer float, whatever. Then they're using an integer float as key. And then you can even have dictionary, sub-dictionary. So this is just like, this thing is like a mutt. You can throw whatever you want in it. Right? And then to get to that dictionary, how do you get to it? I mean, this is fantastic, but how do you get to, oh, it's right here. So yeah, I was doing it right. Basically, this is the dict. Wait, what? My dict. Right? Okay, this is the key for that dictionary, and then this is the, got it. Yeah, so I had the right idea. Okay, so let's go back. Where is it? Where are you? Probably looking right at it and can't see it anymore. That's when you know it's time to walk away, but we're so close. Okay, here it is. Yeah, and this should give me back the stuff that we just saved. So let's save this, right? And it's going to clear it, right? It's going to tell me there's nothing in it. So it's wiping out the persistent entities section, completely getting rid of that. So there should be absolutely nothing. And then here it's going to just load the entire thing. So let's go back, check, and we got an error. Invalid index. Oh, it did it. Well, would you look at that? It works. What the heck? It actually works. Well, I'll be. Holy smacks. I did not expect that to happen. Um, I want to know something else also. I want to know print I and E. I want to know what these are. Oops. Oh, it's returning the key. I gotcha. So, yep, it's doing it correctly. This is the first key, and this is the second key. I don't understand. When I put one the first time, it didn't read it proper. But regardless, we know it's working now because we're clearing the entire dictionary. And then when we load it, it's actually repopulating the dictionary with what the stuff that we cleared out of it already. And then when we get here, it's then doing the right thing, which is letting it know. So we just handled the data properly. This is actually better than what I thought was going to happen. This is very good. This is excellent. This is perfect. This is what I thought this was going to do, but it didn't. It made us have to now type all of this stuff out, which is fine. Right? This is absolutely fine. It actually saves us a little bit because we don't need to instantiate or instance a new instance of, or make a new instance of a data type class. So we can actually get rid of that data class altogether. Later on, you don't need it, which is cool, which is nice. Or maybe we can test it out when I test out the resources stuff. We can actually use it for that. This works. We're going to do one more thing, which is I want to do a quick populate on this thing, right? So in order to do that, we need a we need to run update on this. So basically what needs to happen first is we want to call add entity, and we're going to do nothing, right? We're not going to add anything. Then we're going to say we want to get the entity. So we're going to first call add entity, or sorry, we're first going to do get entity, right? We actually don't need to call add entity. We're just going to call get entity. And get entity is going to then say, hey, this thing, it doesn't exist in memory, right? We don't have anything like this. So then what I'm going to say is, okay, if you don't have anything like this, what I want you to do is I want you to update the entity with the stuff that's already in this. And from there, and this is going to happen on ready. And then from there, we're going to call this. And this should now iterate through that, and it's going to print out all of this stuff. This will be the final test to find out if this thing is saving properly or not, and if my system has any validity to it. So this is the final part. Okay. Instance entity, persistent entity. Here we go. So in persistence entity, we're going to have a func, and we're going to call it initialize. Initialize persistent data. Okay, so this whole thing is just basically set up the persistent data, right? So before it does anything, it's going to do a get. Let's actually go down one level to, because we were just testing things out, so now we have that stuff already. Let's go down here, and we can just grab, what the heck? Oh yeah, okay, so we can just grab this, and we can go back up a level. Let's just put pass here for now. So now let's go up one level, persistent entity. Boom. Okay. So now, with that, we've managed to get that node, and the next step is to do a test dot get where is it? Persistent entity. We need to do a get entity. There we go. I don't know why it's not coming up, but get entity. Okay, and we're going to get this thing's persistent ID, which is nothing, right? And so now when this thing initializes, it's going to say, yeah, I want you to get this entity. And now also it wants to know, is player, right? So let's go back to get entity. We haven't put this in yet, and we don't really need it there yet, but it's something that is uh, weird. It's so weird. Why is this thing not picking up? This isn't picking up either. Whatever. Whatever. This was working, so that's probably gonna work. So now, so now we're doing this. We're gonna say, okay, I want you to get the entity. Okay, and we're gonna say var data is equal to get. There we go. Okay. So now from this, we can say that the um, entity name is going to be equal to data dot weird. What am I returning exactly? I am returning that. Okay, that makes sense. That sort of makes sense. No, it doesn't make sense. Doesn't make sense at all, actually. It should be. It should be. Enums dot. Oh, I think you can do it that way, but I'm assuming that, yeah, enums dot property into the property dot name. Right? That's what it should be. And then persistent ID is going to be equal to data. And this is what I mean. Yeah, there we go. ID. This is what I mean by, like, I don't have to worry about anything like that. It should just fill that stuff out. Um, so let's just grab this. Go back to this, go down here, do this, and then just toggle the comments. Okay. First, what's this name? So we're looking for the entity state should be equal to data. I actually like this. This is pretty fun. Oops. Health going to be equal to data. Max health. The good thing about Unity is that it would have started filling these things out for me. But uh like I could just keep pressing tab because it would have a good, well, it's not even Unity, it's more like the IDE would know exactly what I was going into from this point going forward. So it's just tab, 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 tab. But with this, you have to type the whole damn thing out. Max health. All right. And kind of why my habit of building them out first as enums didn't really matter much because it didn't take much. I would just tab through the enums as it would autofill in. Age equal to now this isn't the actual way that we're going to be doing this. So um yeah, this isn't the actual way we're going to be doing this. We're actually going to be uh putting this after, because what will happen is we're going to be we're going to be putting the persistent data first, but then we're going to put the rest of this after the load, because what will happen is this will be overwritten with zeros, I believe, right? That's what should happen. So we don't want that to happen. We also probably want to put like a has check on these before right? That's what's going to happen. We're going to do a get entity. And we throw in the persistent ID and we throw in is player. And then get entity. Oops. Get entity. Oh, let's see what GPT says. Yep, there it is. So yeah, same thing. Okay, so get entity would be this. You never know. Sometimes when you go through like GPT, you'll end up getting really nifty ways of handling certain things. But you can always just refer to the documentation as well. And if all else fails, then search engines. Like that's my third go-to. If I can't get anything on the docs, or if I just can't find it, and then I can't, GPT has is giving me like nonsense, or just can't. Believe me, it'll give you freaking nonsense sometimes. But if you can't find it, then yeah, Google or DuckDuck or whatever you're using. Um, we're almost done here, so let me focus up. This is where I start losing focus. So let's focus up. Um, so yeah, basically this is update entity is what needs to get called before anything else. So we're going to go here, back to the persistent entity. And the very first thing that we're going to do is when we do get entity, then we're going to set the entity's persistent ID, right? And then after we do that, then we're going to do update data test dot update update entity and pass in this thing's data. Self, right? And so from here, it should be sending back its data for that's expecting. And then once it does that, then we're going to call this stuff now to populate the rest of the data. So let's finish this off now. Enums entity property dot max speed and max speed, and the last one was what? Acceleration. Data enums entity property acceleration. Okay, done. Now once that's done, it should populate basically what this is doing is we're going to say that this had data on it to begin with. If it did, then this is going to update the this entity that we got here, right? Because first we have to get an entity, right? And we're going to throw in the persistent ID. And the persistent ID is nothing, so it's going to generate a new persistent ID for us. And it's going to check to see if it is the player. We haven't implemented this. I don't think we're going to implement it yet. Not today anyway. But the idea is it's going to first check, or the goal is for it to first check if we're talking to the player. If we're not, then it's just going to check the persistent. It's just going to check the persistent ID. And then from there, it will go through IDs. And to this, it'll basically sync up the ID that it got from the get entity to this. And this is initially, right? So whenever we first start the game, this should be a blank slate, whatever this is. All we're doing is just getting the information from data. And if it doesn't exist, then we create it. And then we set this to being it. We update any data that's on this. Even though this should be blank, it might have data on it. And if it does, we want that data to go hmm, let's do something here. I think I have an idea. Okay. So we have this, which is going to say is new. And if it is new, basically, then we go through this process. over here, right? So if there you go. If persistent data ID is new is equal to false. Okay, there. So if this thing already has an ID, then it's false. This part over here is going to just get this information, right? And so once it gets once it gets an entity, uh, it right. So now if is new is false, right? So if is new, right? So if it is new, then we want to yeah, okay, there we go. So if it is new, we want to do that, right? So if there's no ID, do we need to do that? Yeah, so I don't think we even need the is new. We can just put it here. All right. So if persistent ID. So first we do a check, see if it has a persistent ID first, and then if it does, if it doesn't have a persistent ID, then we're going to set the persistent ID, and then we're going to update it with any values that it has on itself. If it already has a persistent ID, in other words, it already exists in the list, instead it's just going to update, or it's going to take from the save list this information and say, hey, this is my information now, right? That's how that works. Yeah, that's how that works. So in order to get this now, so this is doing quite a few things in one method, right? I don't like that it's doing quite a few things in one method, but it's doing them. And it's just a test anyway. So, oops. So let's test it. Let's see if it works. If it works, we're done. So here comes errors incoming. Oh, would you look at that? It works. Okay. So yeah. It didn't work actually. It's not working. Right? Or I just did the logic very poorly. Um yeah, so it's not reaching here for some reason. So there we go. Let's try that. See if we get this far. Hmm. Oh, I'm a dummy. I'm a dummy. Okay, so we are here. Where are we? First get the name for this. And then we go here, and we are just going to do this. Now we should be good. Get errors. Okay, so the first error that we get is persistent initialize, persistent. What are we worried about here? At line 18. So it should not have gotten here unless this happened. So actually, let's do this. Let's do a quick test. Like I said, this is doing too much stuff. Comment. And let's just do a quick test to find out. Print updated entity. Okay, do that. See what happens. Updated entity. So it did run this, right? All right, so it did run this. So now when we do oh, I know what's happening. I see the problem. I see and I understand the problem. Okay, so this is very, very simple. Data is going to be equal to test update entity, and update entity is going to return entity. Where is it? Persistent data manager. There we go. Update entity. There you go. Update entity. So this returns null. This return persistent entities. Um, there we go. Okay, that should. Yeah, there's some logic that needs to be implemented here. I just don't want them to be doing too many things. But it's not difficult. I could have sworn you could return null on this, but I guess not. So instead, what we're going to do is we're going to do a return of, we're going to do a return of get entity. All right, you're going to just do a return of get entity, and it's going to be is player. How do you do that in Godot? That's the question. How do you do it in Unity? Huh. Damn it. Okay. Yeah. All right. So data dot persistent b and data dot is player. Okay. So effectively, what happens here is this is going to say, hey, get entity. I want you to do that, but instead, what I want is not for this. I want this to do this. I want this to take in this as a data type. Why not? I can do it. So we go here, we replace this with that. We never implemented anything. Why not? Cannot have a mandatory parameters for optional parameters. Oh, after. Yeah, that's true. So this is going to be equal. Um, and so this can be data. Okay, and then we say so this is the situation where we have no ID, we generate a new ID. Add the entity with that new ID. We do a check if data, then data dot entity present persistent ID is going to be equal to ID new ID. Right, there we go. So we set it from here. So now when we go over here, we don't need to do a set. It'll handle it on its own. Where are you? Dungeon player, entity, persistent entity. Right, so we don't need this. Right? Right, so first we do get entity. Why are we doing get entity? This doesn't work anymore. So we can do self, I guess. We don't really need that anymore anyway, so let's get rid of this. This is just trying to get that. Okay. So the very first thing that we want to do is we want to do a var data is going to be equal to update entity. And then when we call update entity, it's going to do this. Where is it? Update entity is going to say, hey, yeah, this is better actually. I like this. So hey, does this have ID? And is the ID not the ID? Here's what I have. I'm going to say, okay, got you. And then generate and then return. Otherwise, it's going to generate an ID. Then it's going to add that entity. And then it's going to do this, which is it's going to say hey, oh wait, yeah, it's gonna say, hey, um, is this circular? No, it's not. Okay, so yeah, so basically update entity is called, get entity, the ID is null, we get the entity. Entity goes here, goes to this part, and it says generate ID. It's going to add a new ID, and data, you say, hey, is the data null? In other words, did we provide data, which we should. There might be cases we don't. All right. Then it's going to say data.persistent ID is going to be equal to that new ID. So we set that data up. And then we go back and we say return um, the entity. So this is basically a blank. This is doing get entity. This is a blank entity, right? This is just it. All it has on it is the ID. So then we need to get back to this part. So maybe I should just do get entity and not do update entity, right? Because update entity is basically, this is like a safeguard to make sure that you don't get to here. So where you're polluting the dictionary data with blank information. It's basically going to say, hey, or with just default information that shouldn't be there, I guess. It's going to say, hey, I want blank information here. And that's like a clear flag. Yeah, it's initializing. For me, like, let's say some player comes to me and says, hey, my game characters, and I'm going to look at it and say, oh, yeah, that's going to happen because you're initializing data on a character that doesn't exist and say in your save. So that means you probably tried to create a character or something like that, or created data in the game without having a save file. So when you did go to save, it ran with whatever was on the default for the character, and it becomes very obvious at that point. That's the idea. In the same breath, that should never happen if I do this system correctly, right? So, all right, so I think we can call that a wash on this part. We don't need this here. We're going to just do data is equal to get entity. And then in get entity, we're going to put the self. Am I doing that right? No, it's update get entity. We're going to put the ID data. I mean, we shouldn't have to do this, but and self. We should just be able to put self, I'll be honest. So let's just do that. No need to put extra stuff that we don't need in here. Get rid of this. And then replace this with data dot persistent ID. Okay, yeah, that's better. Okay, and then finally, let's go back to this for a second. So get entity is going to either return the whatever it finds, or it's going to create a new thing and then return that new thing. And so now we want it to take, if it's returning this, we actually want to call this. update entity. And we want to put in data. Right? And this can't be null anymore. You have to provide it. So we update the entity with data. And then it's going to just run this. So this is circular now, right? But it's only circular first time. There we go. So it's only circular the first time. Or rather, it shouldn't be circular at all. Like if you call update and there's nothing here, then it's going to go into this. Then this is going to right here, give an ID. Then it's going to throw it back to update. And then update's going to say, yeah, I have an ID now. Here's the rest of this information. And then from there, it's going to add this new data in. And it's going to return out the dictionary in case we need it for something. Good enough. Let's go back to Dungeon Player. And, well, no, let's go back to Persistent. Okay, so now that get entity is handling that by itself. It should never overwrite any default settings on the player itself unless the player has an ID that already exists in it, right? So now when we call the initialize, this is us saying, let's just double check get entity real quick. Because this should only happen if, or the update part should only happen if there's no ID. Right? But if there is an ID, then if there is no ID, then it's going to create an ID. And it's going to then grab any information that might be default on the character and then store it in the dictionary in update. And then when I go here, then it's going to populate this part. So let's first undo this. Well, not undo, untoggle. Let it off. Okay, so this is fine. So now what this is going to do is this is going to overwrite this information now, right? So we have a situation where let's say we want to put this in. Like, let's say we want to make one, right? And made for that particular instance, that's the player, let's say. We want that particular instance to have that particular ID. So then what? The solution is this thing is kind of fishy to me right now. I'm kind of sus on it. Right? Like, I get what it's supposed to be doing, and it did what I wanted it to do, but now I'm second guessing my logic here. So we run a get entity call. We see that it has, but then we return what it has. And then when we go back to the other thing, we're just returning, we're populating back based on what it has. Otherwise, we're creating a blank one, and then we're going to call update on that blank one, just this. And then we're going to grab all of the data that might be on the blank one and populate it with whatever is currently on that. And still we're returning that dictionary. So it's just going to be doing the same, keeping the same. Is now we're going to do a save load on that. So this is wrong because we want to do test, save, and load. This is wrong because we want to do a save and load on it. Actually, no, it's fine because we're doing a clear within the test, save, and load, right? So the goal is we save the information, clear it, and then we load the information. And we're going to iterate through it to see if what we loaded is the information that's default on the entity. We're not overriding anything on the entity. Nothing here should be blank, in other words, right? Because we're ensuring that the template entity stuff is stored into JSON before anything. If anything, we're overriding the JSON files, which is what I should be doing, which is what I want to do. So let's go here. Error? Okay. Too few arguments on get entity. So this, we don't need this anymore. Okay, let's see now. Looks like it worked. Let's go to close this. You want to reload it? Yes. Here we go. So key 11 had a value of 10, 50. Yep, we're good. We are good. The downside of this system, however, is that all of these values, right, are kind of ambiguous. But this is the system that works. We got it. Okay, we're done. Not bad. Not bad at all. All right, we now have a save load system. Let's go over to the tasks and we finish this and we finished this and we didn't make the instance character entity structure. So I guess we're gonna do but we did sort of start doing this and we have to, I guess a part of the instance would be the enemy. So this is going to be the resource stuff. So tomorrow I'll hit this. But for now, I'm happy with what we have, which is this. This is basically showing me that it did read the information, it picked it up, and it brought back the information from JSON into Godot, right? So it's reading the information. Yeah. So that's it. It's this is just extra stuff, right? It's just constantly reading the same thing. But basically the value, you know what, let's clean it up a little bit so you can see more clearly um, what's happening there. Da, 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 da. So let's get rid of this, get rid of this. So we're gonna leave this, and we're gonna put this over here. All right, and so this is gonna show us the key, and it's gonna show us the underneath it, the there we go. So this is the key, this is its content. Actually, let's do it like this. Yeah, that makes it easier, I think. All right, there we go. So that key is 0, value, we don't have any value on this yet. That would basically be the entity name. It doesn't have a name. We can set that later. Uh, we have uh, key here for 1, value here, 2, 0, 3, 0, so on and so forth. But yeah, this is like the speed. So if you remember the character, where is it? Level test, dungeon player. So here it is, 10, 50, 10. So this is 10, 50, 10. Right? That's what this is. So it's doing it. It's doing it properly. It's doing it fine. Um, okay. I think that's it. We're good to go. We're gonna call it there. That was a good session. Thank you for watching.